Hello guys, so I want us to do probability and probability distribution. Uh, so we shall start with the definition, then we talk about the terminologies available, then later we get into probability distribution. So let us start with the probability. Let us start with probability. So when we talk about probabilities, as you can see, probability refers to the measure of chance of likelihood that an event will take place or it might not take place. So when we measure chances or the likelihood of occurrence of an event which might take place or not, is what we mean by the word probability. Now probability is given by the desired outcome. You divide it by all the probability outcomes or all the available outcomes. Let us see some of the terms used. Number one is the sample space. Sample space refers to the group of all the events relating to a given experiment. So when we talk about a group of events which relates to a particular form of experiment, we mean sample space. Then you have mutually exclusive event. These are events whereby the happening of one prevents the happening of the other one. So it means that if one takes place, the other one cannot take place. So it is described by the word or. So you use the word or to describe a mutually exclusive project, and it is handled using the addition rule of the probability. Number three, we have the independent project. Independent, it's supposed to be independent projects. So independent project or events, let's say events. Let us not use the word project, let us use the word events, because events are the probabilities. So events taking place or not. So independent events, these are events which cannot happen together or they cannot be undertaken simultaneously. They cannot happen at the same time. So events which cannot happen together, or you can say that these are events which cannot happen simultaneously. They are described using the word and is handled using the multiplicative rule of probability. So we use the multiplicative rule of probability. We shall talk about multiplicative rule later. Then you have the dependent events. These are events whose happening of one depends on the happening of another one. So these are events whose happening depends. So whose happening depends on happening of the another event. So meaning one event cannot happen if the other one has not yet happened. So these are events whose happening of one depends on the happening of the other one. We also call it the conditional events. We also call them the conditional events. And we use the concept of a bias rule or the Bayesian rule. So we use the Bayesian rule to compute the conditional probability as follows. We shall come back to conditional computation of conditional probability later, but that is the format. So we are still under terms. Marginal probability. So marginal probability refers to the probability of an event whose happening is not influenced by another event. So it is the opposite of dependent. So this one event depends or is influenced by the happening of another one. But for marginal, one event is not influenced by the happening of the other one. Then you have the joint probability. Joint probability refers to product of the several probability. So that one refers to the product of the several probability. Let's see type of probability. We have two types of probabilities which we shall use in this chapter. So you have subjective, or we call them the axiomatic or the theoretical probabilities. So these are the probabilities obtained without doing a particular experiment. So those probabilities that it is from maybe they are derived from opinion, from feelings, or from theories. Is what we call the subjective. So they are not based on any actual experiment. Then you have the objective. We call them the empirical. So they are based on results of actual experiment. So when we do an experiment, then we call it objective probability. So let us see the solution for this one. So addition rule. So addition rule, we use this is used to analyze mutually exclusive events, and we say that mutually exclusive events, these are events whose happening, where the happening of one event prevents the happening of the other one, and we use the or. So or is described using the addition sign. So let us do it together. Solution. Now, so probability that, let us say probability that only one win. So let us say that only one wins. So the probability that only one wins will be equal to probability of A or probability of B or probability of C or probability of D. So let us start with the probability of A, which is 1 over 4 times 1 over 5 plus 1 over 5 plus, so 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7. So we add them together. So 1 over 4 plus 1 over 5 plus 1 over 6 plus 1 over 7. So I'm getting 0.76. So the probability that only one will win is equal to, the probability that only one will win equals to how much? Equals to 0.76. Equals to 0.76. 0.76. Let's do another illustration. So suppose 80% of tourists who came to Kenya will visit Nairobi, and 70% will visit Kisumu, and 60% will visit both cities. Will visit both cities. What is the probability that a tourist will visit Nairobi or Kisumu? The keyword here is the word Nairobi or Kisumu. Probability that will visit Nairobi or Kisumu. Remember not both. So remember not both city, but only Nairobi and or Kisumu. Nairobi or Kisumu, but not both. So that will be equal to probability of Nairobi, probability of visiting Nairobi, the probability of visiting Nairobi, or probability of visiting Kisumu, but not both. But not probability of visiting both. So both utaandikaje? Both. Let us use the word both. But not both. So what will that be? It will be equal to probability of n plus probability of k minus probability of both city. So let's see. Probability that this person will visit Nairobi is 0.8 plus probability that this person will visit Kisumu is 0.7. Then probability that will visit both, which we don't want. We don't want both. We just want Nairobi or Kisumu, but we don't want the probability that this person will visit both. So that will be equal to 0.8 plus 0.7 minus 0.6. That will be equal to 0.9. 0.9. So that is the probability that this person will visit both will visit Nairobi or Kisumu, but not both. Let us go to the next item. That is, after additional rule number 2, let us go to multiplicative rule. Multiplicative rule. Multiplicative rule. Multiplicative rule. So let us see this one. Multiplicative rule. So it used to analyze the independent events. And remember, we said when we talk about independent events, we use and. And means additional sign. So and means additional sign. So these are events which can happen together. So independent events, these are events which can happen together. So let us see this illustration. A can hit a target 4 times in 5 trials. Then B 3 times in 4 trials, and C 2 times in 3 trials. So we are supposed to calculate the probability that number 1 all will hit. So all the can will hit the target. So number 1, you are supposed to calculate the probability that all will hit. So all will hit. This one we are going to use. So A, probability of A or probability of B or probability of C. So probability of A, B, and C. That will be equal to what? So A is equal to 4 over 5. That will hit 4 over 5. Remember, I used the word sign. B 3 over 4. And the other one is 2 over 3. So what will be the probability? So the probability will be equal to what when we multiply? So remember, this project can happen together. So remember, this project can happen together at the same time. There is no restriction. So not that only one, but this one is all project will open. So will happen 4 over 5 times 3 over 4. 3 over 4 times 2 over 3. So the answer is 0.4. So 0.4. So that's number 1. Number 2, probability that B and C. And the keyword is that the keyword here is the word and. So and means multiplication also. So B, probability of B is 3 over 4 times probability of C. C is 2 over 3. But remember, this is the probability of happening. So happening means that B and C will hit. But remember, we still have A. Remember, our A is 4 over 5. This one is happening. So what about A not happening? Is equal to 1 minus 4 over 5, which is 1 minus 4 over 5. 1 over 5. So not happening. So not happening, we need to accumulate it here. So probability of B and C happening, but A not happening. But A not happening. So 3 over 4. That is what it means. So B and C means B and C will happen, but A will not happen. But A will not happen. So we need to put A not happening. 2 over 3 times 1 over 5. This is 1 over 10 or 0.1. Number 3. probability of C and A. C is 2 over 3. A is 4 over 5. But remember we have 1, C, A, and B. So B not happening. So B happening is 3 over 4. B not happening is 1 minus 3 over 4. So 1 minus 3 over 4. 1 over 4. So 2 over 3. 4 over 5. 1 over 4. So it is 0.13. 0.133. So those are the answers. So you need to know that one. So probability. So this one means, if I could say, supposed to be probability of B and C happening, but not A. That's what it means. This one means probability of B and C, probability of C and A happening, but not B. But not boy. Let's go to the next, number 3, Bayesian rule. Number 3, Bayesian rule. Number 3, Bayesian rule. Bayesian rule. Let us read this example and see. Now the example says, consider 3 identical bags. So we have 3 bags, A, B, and C. Bag A contains 2 golds. Bag B contains 2 silver and 2 silvers, and bag C contains 1 silver and 1 gold. Number 1, we have to calculate a probability of selecting bag A out of the 3 bags. So probability, so number 1, solution. Number 1, probability of selecting bag A out of the 3 bags. Out of the 3 bags. So bag B, bag A, B, and C. So what is the probability? It will be equal to 1 over 3. That is the probability of selecting bag A out of the 3 bags, because we do not have the probability of the bags, so we shall have the same ratio. So even probability of selecting bag B out of the 3, it will be equal to 1 over 3. Probability of selecting bag C will also be the same. That is number 1, or number A. Number boy, or number B, probability of selecting a gold coin from bag A. So we are saying probability given gold given A. Probability of gold given A. So probability of gold not gold. Probability of A, bag A, given gold. So that will be equal to what? It will be equal to the probability of gold given A multiply with what? Multiply with probability of A divided by with probability of the last one, G. So that's the same as saying the one here, the same thing. So let us see, what is the probability of gold given A? Probability of gold given A. So bag A contains 2 gold. So bag A contains 2 gold. So bag A contains 2 gold. So 2 golds, 2 over 2. 2 over 2 times probability of A, which is 1 over 3. We have seen it here, probability of A, which is 1 over 3. So bag A contains 2 gold. So 2 gold to be 2 over 2. So if it is 3 gold, 3 over 3. So, but it contains 2 gold, so it's 2 over 2 over probability of gold. Now, probability of gold is how much? Probability of gold is the first one. Bag A contains 2 golds, which is 2 over 2 for bag A times 1 over 3. That's bag A. Let's go to the next bag. Bag B contains 2 silver. Contains 2 silver, so meaning gold is 0. There is no gold. There is no gold. There is no gold in bag 2. But we have 2 silver. So total items is 2. So divided by 2, but gold is 0. But probability of bag 2, remember probability of bag 2 will be also bag B. Will be also to be equal to 1 over 3. So I'm multiplying with 1 over 3. Plus, so gold. That's equal to C. That's equal to, so bag C contains 1 silver and 1 gold. So 1 gold, which 1 over 2 times 1 over 3. Because also probability of bag C is 1 over 3. So remember this C. That one is correct. So when you do this one, you shall get the answer. And the answer is 2 over 3. So remember probability of G means, probability of G means we take probability of, we take the probability of gold given A plus probability of gold given B plus probability of gold given C. Given C. So meaning this formula can be written as follows. So probability of A, bag A given G, will be equal to the probability of bag G given A, probability of gold. So probability of bag A given gold is equal to probability of gold given A times over the probability of A over, now rather than writing probability of G, you can write P G given A, P G given B plus P G given C. This and this is the same thing. That's what we have done. So probability of G given C. Now, that is one of the illustrations that you need to understand of Bayesian probability. For example, also you can be given this kind of a probability of B given A. What does it mean? It means probability of A given G times probability of G. Is that correct? Then we divide it with the probability of A. Divide it with the probability of A. So in short, you reverse. So probability of B given A, you start with now A given B. Sorry, A given B. This is supposed to be A given B. Then you multiply with A. I will multiply with B. You multiply with B. That is correct. Then you multiply with, we divide it with A. Let's see another illustration. Let's see another illustration, and then we see if we can do it. Let us see another illustration for the purpose of illustration. Yes, so we need to do some questions for you to understand. Let us see another illustration. Let us see when a machine is set correctly. When a machine is set correctly, it produces 25% defective. Otherwise, it produces 60% defective. The chance that the machine is maintained correctly is 50%. The machine was set, and before commencement, the production of one piece was infected and thought to be defective. What is the probability that the machine was set correctly? What is the probability that the machine is set correctly? So let's say that probability given that the machine probability that machine is set correctly given defective. So probability of machine is set correctly given it is defective. Now this one will be equal to the probability of D defective given it is done correctly times the probability of is this done correctly divided with the probability of D, given the probability of D. Now we can try and expand. So let us expand the probability of D. Now probability of D is equals to what? Is equals to probability of D given C is done correctly times C times the probability of C not done correctly. So done correctly, sorry. Then plus, so correctly and not correctly. So the probability of D, we need to check the one for correctly done, if it is well done correctly, and the one for not correctly done, because we have two items, not correctly done. Now let us start with the correctly done. Now if it is correctly done, so probability of D, it is well done, we multiply with probability of well done over with plus probability of D not correctly done. So when I put C and something above, this means not well done. Multiply the probability of C not well done, so that we get all the total probability. So let us see. So let us see how we can do that one. Okay. Now, let us see with the probability of D. What is the probability of D that is defective given that the item was done correctly? D given that the item was done correctly. That will be equal to D. When a machine is set correctly, it produces 0.25% defective. So defective is 0.25 done correctly. So that is done correctly. So correctly and defective is 25%. We multiply with the probability that it is correct. The probability that is correct is 50%, so 0.5. So the probability that C is correct, or probability of correct is 0.5. Now we divide by probability of D and C, which is 0.25 times 0.5 C plus now D but not well done or not correctly done. So otherwise it produces 60% defective. Otherwise, so otherwise means now if it is correct, the otherwise is not correct. So the not correct is 0.6 times now not correct. So correct is 50%. So not correct is also, so 1 minus 0.5, which is also 0.5. So what will be the probability? The probability will be equal to 0.294. So the probability will be equal to 0.294. That is correct. Let us look for another question. The last question for biennial conditional probability. Let us do another question. So let us try and analyze this question. So in a certain before we do this example, let's see what is contingency table. A contingency table is a table which is used to analyze conditional events or the independent events. It is applied to mutually exclusive events, and then each events or experiment must be divisible, or they can be divided further. So that's another thing you need to know. Then the value of the sets represent the intersections of the sets applicable, and then they are analyzed or corrected using the multiplicative sign, that is the and. That is for the intersection. So the intersection or the value in the sets, you analyze them using the and. Then we have the totals, of the row and columns. The totals of row and columns, they are described as union of sets, and therefore we use the addition sign or when we are adding them together. The table can also be used to deal with the Bayesian rule in some situation. Now let us see this example. In a certain factory, which in a certain factories which employs 500 men, 2% have minor accident in a given year. Of this, 30% had safety instruction, whereas 80% of the employees had no safety instruction required. Probability of an employee being accident free. So probability of an employee being accident free and had no safety instruction. So let us add required probability of an employee being accident free and had no safety instruction and had no safety instruction. So let us see. Let us analyze. Now we are going to analyze using the table. This one. Our table will be in this format. Let us try and draw a table. So we have a instruction. Just put it instruction. That format, that instruction, then accident. So we have accident, instruction and accident, and then number one, given instruction. Let us say given instruction. Then not given instruction. Here not given instruction. Then you have total, and then this total, we have said the totals represent a union of set. So remember these totals, and we also have totals in the other side. So we have free, we have minor, then total. So you have said total represent what? Total represent a union of set. Then you have the cells. These are the cells. So these are the cells. So we have this cell 1, this cell, and this cell. So those cells represent what? The intersection. So the cells represent intersections. Then the total cells, these ones, represent what? Represent the union. So in a certain factory which employs 500 men, 2% had minor accident in a given year. So 2% had minor accident. And had a safety instruction of 80%. Had safety instruction, whereas 80% of the employees had no safety instruction. Require probability that an employee had been accident free and had no safety instruction. Now let us start to analyze. Let us start to analyze. Now the first one is 2%. 2% had minor accident. 2% had minor accident. Let us see. 2% had minor accident. So 2% means 2 over 100 times 500 men had minor accident. So minor accident. Had minor accident. So what is 2% of 500? This is 10 people. So 10 people, the total of these 10 people had minor accident. So 10 people had minor accident. So that is number one. That is the first analysis. Let's go to the next analysis. The next analysis is of this 30% had safety instruction. So now of this 10, 30% had what? 30% had safety instruction. So safety instruction, so given instruction, so G instruction, so given instruction. So out of these 10 people, 30% already were given. So 30 over 100, let us say 30 over 100 had already been provided with safety instruction. That is how many people? 3 people. So for under minor, 3 people already. 3 people already were provided. 3 people already were provided with the safety instruction. Then, whereas 80% of the employee had no safety instruction. So 80% of the employees. So 80% of the employee had no safety. G, not given. Let us say not given instruction. Not given instruction. So 80% of those people were not provided with, supposed to be 500. 80% of those people were not provided with instructions. So 80% of these people are 400 people. So 400 people were not provided with any instruction total. So 400 people were not provided with instruction. 400 people are not provided with instruction. Let us now with that information, we can fill the table. Remember our total. Remember already by default we know our total men is 500. This is our total. On this side, this side, and also on this side, we need to have total of 500 men. Now let us now analyze. Where is my calculator? We analyze. So how many people are remaining to make 500? So here it is 490. So 490 plus 10 to give us 500. Then on this side, how many people to give us? 500, 400, and in this case is 100 people. Then how many people to give us 10? 7. So 7 plus 3 will give us 10. Now how many people to give us 100? 97 plus 3. And 7 plus 3 will give us 100. Now how many people to give us 400? So this one is 393. So 393 plus 7 will give us 400. And the 393 plus 97 will give us 400. That's our table. That is our table. Now we are required to determine probability of an employee being accident free. Probability of an employee being accident free. Given there was no any safety instruction. So probability of an employee being accident free. So we say accident free, given no instruction. So N means no instruction. So probability of that one What will be that? That one means it is the probability. So probability, that will be probability of n f. What will be the probability of f over probability of n? So I say probability of free of no instruction but free. No instruction but free is 393. 393. And this one is the total probability actually, because we cannot say and free alone. We cannot. So it will be 393 in that format. Over the probability of n. Probability of n is 400. That will be the answer. That one will be the answer, because we cannot say, or we cannot probability of n and f. So n and f is 393. Probability of f alone. Probability of f alone we do not have. We do not have the probability of, or you can say probability of f alone is 1, because it is 97 plus 393 divided by the total, which is the same. So for 90 over 490, which is the same as 490 over 490. Or we can say probability of free, given that this one is free, is 93. What if you say 97 over? Let us see, 97. No, that is the only way. That is the only way we can do it. That's the way. So probability of Fn is 93 over 400. We can look for another probability. Let us look for a probability that he was accident free given instruction. Probability that he was accident free. Probability that he was accident free given instruction. So what would be that? Probability that was accident free, but it was given instruction. It is 97. So it will be equal to 97 over 100. So the answer is 97 over 100. So don't need to confuse yourself with these items. This one is, for table, will be direct. Probability of free, given that there was no instruction, is 393 over 400. Get the answer. So that is direct. So the answer here is 0.97. And this one is 393 over 400. 393 divided by 400 is 0.98. So that is all about the contingency table. That is all about the contingency table that you need to know. Let us go to continuous methods. So let's see combination. So this is the continuous method. Call them continuous method, or call them the method of counting. You can call them the method of counting. So we have combination and permutation. So combination, these are techniques used to establish the number of ways in which different items can be arranged. Selecting R different items of time without regard to specific order. For example, n combination R. So n combination R is equals to what? So it's equals to, for example, let us see, what is a 10 combination 4? So 10 combination 4 is equals to 210. So we can combine 10 and 4 200 times. So we can combine 10 and 4 200 times. So how do we get this 210? It is 10 combination 4. So in your calculator, you take 10 Then combination, we have it here. It is written POL. So just click it here. So 10 combination 4, that will be equal to 210. 210. 210. So we are, let me repeat again. So 10, then we click this item, this one combination 4, give us 210. Let us see permutation. This is a technique which are used to determine the number of ways in which n different items can be arranged, selecting R item or of time with regard to a given order. So for example, 3 permutation 3. So how many times can you arrange this item? So 3 permutation 3. So you take 3. So you take 3. Then permutation, you click shift, then POL, then you click 3. So you get 6. The answer is 6. So shift, then POL. So get 6. So 12 permutation 3. We can arrange these items how many times or how many numbers of ways. So this one can be arranged 19,958 ways. Now let us see the last sub item that will make this topic end, and that is probability distributions. Probability distribution. The first probability distribution we shall start with is the binomial distribution. So probability distribution is our next jump. Probability distribution. So when we talk about binomial distribution, these are discrete distribution used to analyze situation where which satisfy the following condition. Number 1, experiment must have 2 possible outcomes, and which is the success or the failure. And number 2, the probability of success must remain constant. Then you have some characteristics that you need to know. Number 1, experiment consists of repeated trials. Then each experiment has 2 possible outcomes, as we have stated. Then you have the probability of success or the probability of failure, which is denoted by P and Q. Then you have the trials, which are independent. So you have also trials which are independent to each other. The trials are also independent to each other. So let us do a question. And remember, probability of success and probability of failure equals to 1. So you need to know that probability of success plus probability of failure is equals to 1. So P means success, Q means failure. Let us see. Now remember, binomial distribution is given as follows. This is the formula for binomial distribution. N combination R. Let us use X. N combination X multiplied by P X Q N minus X. Now the first one is the percentage of probability that will contain no defective. Now no defective means that defective is 0. So P is equals to R. R is 0. No defective. But remember our N is 100 because the number of boxes is 100. So 100 combination 0 multiply by P. Our P is 0.5. 0.5 raised to 0 because N is 0. X or R, let us say R is 0. Which is our X? We can use X or R. We can use X or R. Let us use X because we are talking about. You can use X or let us use X. So X is 0. Q. So remember, P plus Q is equals to 1. But remember, our P is 0.5. Meaning our Q will be equal to 1 minus P, which is equal to 1 minus 0.5, which is 0.5. So times 0.5, 100 minus 0. When you get that answer, you should get the probability of 0.606. Let us do it together with a calculator. Take your calculator. We start with the 100. Then you click the button below the alpha, which is POL. Combination 0 will give us 1. So this one is 1 multiplied by 0.5 raised to 0, which is 1, times 0.5 raised to 100, which is 7.8 times 10 raised to minus 31. So yes. What is this? A moment. 0.5 0. Sorry. I've made a mistake here. I've made a big mistake. So 0.5 means 0.5% means 0.5 divided by 100. That is 0.5 divided by 100, which is 0.005, which is 0.005 raised to 0 multiply by now 1 minus 0.005. So 1 minus answer, which is 0.995. 0.995 100 minus 0. So this one is 1 times 1, because 0.005 raised to 1 raised to 0, sorry, is 1. Then 0.995 raised to 100 is equal to 0 times 0.605 7. So when you multiply, we shall get 0.6057 or 0.606, or 60%, or you can say 60.6%. So the probability that the box will contain no defect, meaning that all the boxes will be fine, is 60%. Number B. So that's number A. Number B, probability that X will contain what? Will contain 2 or more. Will contain 2 or more. But remember, 2 or more, meaning it can be 2, 3, 4, up to 100. Remember, it can be 2, 3, 4, up to 100. But remember, doing that one will require a lot of time. So what we do, we can do that. We can do only the probability that will contain 1. So that when we get the probability that it will contain 1, the difference we will get the other one. So that's probability that it contain 1 will be equal to 100 combination 1 times 0.005 combination 1 times 0.995 100 minus 1 will be equal to what? What will be the answer? What will be the answer? It will be equal to 0.606. Let us confirm. So 100 combination 1 is 100 times 0.005 raised to 1 to be 0.005 times 0.995 raised to 99, 0.6088. So times 100 times 0.005. Okay, I'm getting 0.304 and not this one. So 0.304. 0.304. Now remember, they wanted the percentage of probability that P, which is X, must be greater than or equal to 2. So remember our total boxes is 100. So
x is greater than 2, it means that we do not want 0 and 1. So meaning our probability will be equal to 1 minus, we take the probability of 0 0.304 plus the one for 0, 0.606. Then we shall get that the probability of defect is more than 2. That will be equal to 0.09 or 9%. I hope you have understand. So what I have done is, remember probability of x is greater than 2. It is very hard to do it, because if you were to do this one, we need to do probability of 2, we do probability of 3, we do probability of 4, up to probability of 100. So we cannot do all this here. It will take a lot of time. So what we do, because they want probability of 2 up to 100, we can do probability of 0 and 1. Probability of 0 and 1. When we get the probability of 2 and 1, then for us to get the rest, we take 1 minus the answer here, so that we can get from 2 up to 100. So that's all about it. Let us go to the next item. The next item is our probability distribution. We are done with it. Let us go to normal distribution. Normal distribution. Normal distribution. Normal distribution. So let us say this one now. Now we talk about normal distribution. So normal distribution assumes that our data is normally distributed. So this is a distribution where the data is usually assumed to be normally distributed. Now it is started by analyzing the value as follows. So the z value the z value is given by x1 minus x bar over the standard deviation. So x1 is the specific value, x bar is the mean, and the denominator is the standard deviation. For normal distribution, standard deviation is assumed to be equal to 1. So for normal distribution, the standard deviation is always assumed to be equal to 1. Now the above normal curve, this curve here is a normal curve, and it is divisible into 2 equal parts. A normal probability distribution should have a mean of 0 and variance of 1. So the mean is 0. So mean is 0, and the standard deviation must be equal to 1. So you need to know that one. So for a normal curve, the mean is equal to 0 and standard deviation equals to 1. So mean here is 0. So the mean is 0 and the standard deviation is 1. Now a set of data which does not have a mean of 0 and variance of 1 is modified to fit the distribution by computing the z value. You need to know that one. So when the data is not normal, the set of data, a set of data which does not have the mean of 0 and the variance of 1 needs to be modified. So it needs to be modified to fit the distribution by computing the z value. So when the mean is not 0 and the standard deviation is not equal to 1, we need to standardize the value by computing the z value. The computed z value is then used to read the probability or the probability of interest. So the z value is then used to read the probability of interest from the normal distribution table. The probability read from the table is probability of interval between x1 and the mean. So when you read the value from the table, it means it is an interval of x1 and the mean. So let's see this question illustration here. Number 1. Okay, number 1. We have the assumption there. You shall read the assumption on your own time. So a survey is conducted on a citizen in a certain country to determine the annual per capita income, indicated that the annual income of the citizen is normally distributed with a mean of Kenya shillings 980,000. So we have a mean of 980,000. So if we draw it here, now our mean says is 980,000, and then you have a standard deviation of 160,000. We have a standard deviation of 160,000. One of the citizens was randomly selected from the country. Required probability that the income of citizen is greater than 500. So remember, we said that the mean must be equal to 0. Now in this case, the mean is 980, meaning it is not normally distributed, and therefore we need to standardize the value using our z. Let us standardize the value. So number 1, z will be equal to x bar x minus x bar over the standard deviation. Now is greater than 500, so 500 is around here. 500 is around here. So it means that we are looking for the probability that the annual income is more than, or it is greater than 500, meaning from this 500 up to this point. And remember, we have this part and we have this part. So from this part of 500, so when we compute, we shall say our x is 500 minus 980,000 divided by the 160,000. How much will that be? That one will be equal to, but we ignore the negative actually, so you ignore the negative. So if you get the negative answer, you ignore. 500 minus 980 divided by 160. So 3. So 3 is our z value. So we go to our table to find the z. The z of 3. When z is 3. So when 3 is 3, it means it's 3.3. This one means it's 3.00. So if you go to our table, you can see that our table is in this form. Yeah, you have 0, 1, 2, blah blah blah. Then you have 0.0, 0.1 up to last item is 3. Now 3.0 is this number here. So you find 3 on your z. Once you find 3, you find 0. So 3.0. So you get that figure. So what is the figure? So the figure is 0.4987. So the z from the table, z is 0.4987. So meaning, if we draw this our table again, now from this point up to this point is 0.4987. So at that point, we know that we have a figure of that one. But remember, we want from this point, up to the last point. So we also need this one. And remember, this point is 0.5. So for us to get the actual probability, it will be 0.4987 from this point up to this point. Then we add from this point up to the end of this point, which is 0.5. So that will be equal to 0.9987 or 99.87%. So that is the probability that it will be greater than 500. Probability that it will be greater than 500. Probability that it will be greater than 500. Let's go to the part B. Part B of that question. So that's how you do part A. So let's go to part B. Part B. Part B says greater than 1200. Greater than 1200. So let us draw it here. So when we draw it, so we have 980 as our mean. Then greater than 1220. So it is greater than 1220. So meaning greater than is this point up to that point. So that's what we need. We don't need the other part. So this part we don't need, we need the other part. So Z will be equal to 1220 minus 980 over 160. So for this one, the answer that you shall get from the table is direct. Okay, not direct, I will show you. Minus 980 divided by 160, 1.5. So we go to our table. As I told you, you go to the Z. From our Z table, you find 1.2. 1.50. So 1.50. So if I go to my table here, our Z, and then I go downwards, I will get 1.5. 1.50 is equals to 0.4. Our Z is equals to 0.4332. 0.4332. But remember, this item is between this. So this figure is between this part and this part, because it's the difference. The difference between an 8 and 20 is this part, between this part to this part. But we need from this part, so this is X, is this one, but we need Y. So remember, our total is 0.5. So for us to get the actual, it will be equal to 0.5 total. We minus this X, which is 0.4332, so that we can get our Y, which is, if we deduct, so 0.5 minus 0.4332, which is 0.0668 or 6.68%. Number 3, we are supposed to do between 852 and 1100. Let us see that one. I hope it is visible. Our mean is 980. Then we have 852. So they want this part inside and this part 1100. Now this one is direct. So the good, when we have two items, when you have been given anything between two items, the answer is direct from the table. So our Z will be equal to the mean, this 1100 minus 852. You ignore the mean. You ignore the mean. You divide by 160. So that one, you ignore the mean. So what will be the difference when you deduct? So deduct and divide. So it will be equal to 1100 minus 852 divided by 160. 1.55. Then you go to the table, you check it direct. So 1.55. So 1.5. So you go to your table. You go to 1.5. So 0, 0.0, 0.1 up to 1.5. Then you come to this point. We have 0, 1, 2 up to 5. So you come and locate that figure here. So 1.5, then 5, 1.55. So from the table I can say it is 0.4393. So our Z is 0.4393. So that one is direct. That is direct. 0. Let us confirm. 1100 minus 852 divide by the 160. 1.55. Then 1.55, 43.94. I'm getting 43.94. Why? Oh, let us do it. Let us not do this. This is incorrect. This one is incorrect. This one is incorrect. What we need to do, let's correct this one. We shall start with the first one. 1100 minus 980 over 160. Then we do the second one. 852 over minus 980 over 160. So that we can get 1100 minus 980 divided by 160. So that is 0.75. Then you look from the table. 852 minus 980 divided by 160. Ignore the negative. You look from the table. Let us look from the table now. That is the correct way. So let us start with 0.8. 0.8 is 0.2881. So 0.2881. Then we have 0.2881. Then you have 0.75. 0.75 is 0.2704. 0.2704. So you add the two so that you get the probability. So you add the two, you get the probability. 0.2704 plus 0.2881. 0.5585 or 55.85% or 55.85%. So that is all about normal distribution. Then you can do the last one, that is Poisson distribution. So once we've done Poisson distribution, I think that one will be the end of our class. So let us look at Poisson distribution. Poisson distribution. Poisson distribution. Now let us see if Poisson distribution. Poisson distribution. Now for Poisson, this is a distribution that is used to analyze situation where events take place in large numbers within a short period of time. For example, arrival of people in a bank. So that's a good example. When you have arrival of people in a bank, maybe when they want to check something, maybe through the teller. So we have those arrivals. So the number of arrival might be large. So we call them the rare occasion, or people entering in a supermarket. So we don't know how many people will enter into supermarket, but we have a lot of people entering supermarket from time to time. So a large occurrence of arrival. So such kind of scenario, we use the Poisson distribution to analyze the information. Now, let us do this question. A survey was conducted to establish the number of faulty components from a production process. The results indicate that 0.01% of the component produced was faulty. Each machine produces 10,000 components required. Probability of there being 3 or more. So we are supposed to calculate probability of X being 3 or more. So that means because we have 1,000 components, we need to do the probability of 3, 4, 5, 6, 7, 8, 9, 10 up to 10,000. But remember, this one is not possible through hand. It is not possible to calculate from the probability of 3, 4, 5, 6, 7, 8, 9, 10 up to 10,000. But what we can do, we can calculate the probability of x x equals to 1, probability of x equals to 2, x equals to 0, x equals to 1, and also probability of x is equals to 2. Then when we get the total of this item, we less 1. So we take 1 minus the total so that we get the probability of 3 to 10,000. Let us do now this form of equation. So we know that the probability of x is equals to our Euler's lambda times lambda x over x factorial. Now our Euler's as normal is 2.7183 raised to our mean. Now we need to calculate our mean. Now remember, mean is equals to P times N. So our mean is equals to P times N. So our N, our P, is probability of success. The results indicate that 0.0 component producers was faulty. So 0.01 times 10,000. How much will that be? So we use the one that is available. So our P will be 0.01 times 10,000. That is 100. That is, remember, 0.01% means 0.01 over 100 times 10,000. So 0.01 divided by 100, because it's percentage, it is percent, so it remains times 10,000. So our mean is 1. So our mean is 1 minus 1 times 1 raised to, when x is 0, over x0 factorial. So let's do this one. 2.7183 raised to minus 1 times 0 times 1 raised to 0. It is 0.3679 over 0 factorial. So it's 0. So you click 0. Then you click shift. Then we have x factorial below shift, the item below shift. So 0. So you click 0. Then shift. Then you click the item below. X. It is written x in our calculator. So shift, then that it is 1. So meaning the probability is 0.3679. Let's go to x. When x is 1, 2.7183. Our mean is 1 normal times our mean is 1 raised to 1, then 1 factorial. So let's do it. 2.7183 raised to minus 1 times 1 raised to 1, which is 0.3679 over 1 factorial is 1. So 0.3679. Same answer. So same answer. Then let's go to the next one. 2.7183 minus 1 times 1 raised to 2 over 2. So 2.7183 raised to minus 1 times 1 raised to 2. Same 0.3679 over 2 factorial. Shift, then equals to 2. It will be 0.3679 divided by 2. So 0.18395. We add. So when we add this together, we shall get the probability that x is equals to x is less than or equal to 3 or equal to 2. We shall get that one. So it will be 0.3679, 0.3679. So this one plus this one plus this one plus 0.18395. So I'm getting 0.91975. But remember, remember our question requires probability that x is greater than or equal to 3. Probability that x is greater than or equal to 3. So meaning it's 3, 4, 5, 6 up to 10,000. Remember our component is 10,000. So meaning our answer will be equal to 1 minus this probability, 0.91975. So that is 1 minus answer 0.08025 or 8.025%. So the probability that more than 3 items will be bad is 80%. Probability that more than 3 items will be bad is 8%. Is 8%. Is 8%. Maybe we can do the last item, exponential distribution. So maybe we do the last item, exponential distribution. Exponential distribution. So let us see the exponential distribution, and this exponential distribution will form the last part of our probability distribution. Now, it is a process in which events occur continuously at a constant average rate. And a good example is the people entering into a hospital to be served. You find even in a bank. So even in a bank, the rate at which people enter to a bank and the rate at which they are being served by the person responsible for serving them. Now, when t is greater than t, we use this formula. When t is less than t, where t kubwa, t for specific t, and then our normal t. When the specific t is greater than the t, we use this formula. When the specific t is less than the t, we use the other formula. When it's between, we use this formula. Now let's see this example so that we can apply. The time taken by a cashier in a given bank to serve a customer is between an exponential distribution with a mean of 15 minutes. Determine the probability that the cashier will be served for a period of at most 10 minutes. So at most 10 minutes. So at most 10 minutes, it means it is this formula, because it is not more than 10, it is not more than 15 minutes. It is not more than, so it is less than 15 minutes. So at most 10 minutes. So 10 minutes is less than the 15 minutes. So we are going to use this formula. P, t is less than t, which is 1 minus our Euler's. So remember our Euler's is 2.7183. I think that is correct. Then minus u. Remember our u is 1 over mean in minutes. So our mean in minutes is, our mean of it is 15 minutes. So 1 over 15 times. Now you need to multiply with the t. Our t is 10 minutes. So our t is 10 minutes. So what will be the answer? So 1 over 15 times 10, which is negative. Remember the answer must be negative. So it will be 2.7183 raised to the answer. So raised to this answer. So we shall get 1 minus 0.5134, and our answer is 0.4866 or 48.66%. So that is the probability that at most 10 minutes will be used. So at most 10 minutes will be used, number one. Number B, between 12 and 10. So we are going to use this formula. So the between. So between T and T. So let us say between T and T. So we are going to use the first one, Euler's 2.7183 negative 1 over 15 times. So let's start with the first one, 20 minutes minus 2.7183 minus 1 over 15 times. The other one is 20 and 12. So what will be the answer? So minus 1 over 15 times 20, 2.7183 raised to answer. So this one is 0.2636 minus 1 over 15 times 12, which is minus 4 over 5, so 2.7183 raised to answer. So let us start with this one. So it's supposed to, this one is supposed to be on this side, this one on the other side, so that will be 0.4493 minus answer. So 0.4493 minus 0.2636. So 0.1857. Let us arrange this one to be correct. Let us this one be 12 and this one be 20. So 0.1857, 1857. So 0.1857. 0.1857. That's correct. Let's go to the number C and our last part. More than 8. More than 8. Now more than 8, we are going to use this formula because it is more than. They are talking about greater than. Greater than. So greater than means more than. So we are going to use that formula. P, even if 8. So even if 8 is not more than 15, they are using the word more than. So remember at most. Remember at most means less than 10. So less than 10, it cannot exceed 10. But at most 8, it means 8 and more. So 8 and more, it can be 8 or more. It can be even more than 15. So it will be 2.7183 negative 1 over 15 times 8. So it will be minus 1 over 15 times, minus 1 over 15 times 8, then 2.7183 raised to answer. So 0.5866 or 58.66%. So that one marks the end of our class, for today's class. That is probability and probability distribution. So make sure you do a lot of questions. So make sure you do a lot of questions. So that's the end. That's the end.